Hello and welcome to Homework 8.00. This is the review homework for the Unit 8 test. So it's got a little bit of everything we've been working on. Alright, let's take a look at number 1. Express each of the following irrational numbers in simplest radical form. Alright, so anytime you're doing radicals, you have to be thinking about your perfect squares. So for example, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and then just on and on. So you've got 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and then 225. That goes all the way up to 15 squared, and that's usually enough for these types of problems. Okay, so how do we actually do them? So we've got radical 72 there, so what we do is we go to our calculator, we go to y equals, we type in 72 divided by x, we bring up our table, we're going to start right here where x is 1, and then we're going to use this y column, and we're going to look for perfect squares. We're going to say, alright, is 72 a perfect square? Nope, it's not on our list over here. Is 36 a perfect square? Yes, it is in our list. So 36 is paired with the 2 here. So this 72 is going to be broken down into radical 36, and notice how I'm putting the perfect square first, times radical 2. All right, because 36 times 2 would bring us right back to 72. Now what we do is we actually take the square root of 36. The square root of 36 is 6, so we write a 6 down there. Notice the radical sign goes away, and then we just leave the radical 2. And that would be our final answer there. All right, so let's try this next one. We've got negative 2 radical 27, so we go to y equals 27 divided by x. All right, 27, not a perfect square. We can skip the decimals. 9 is a perfect square, so we see the 9 is paired with the 3. So this is going to be negative 2, that comes down, times radical 9, times radical 3, because the 9 and the 3 would go to bring us right back to the 27. The square root of 9 is 3, so now that leaves us with negative 2 times 3, and the square root sign went away, and then the radical 3 is still there. Last but not least, negative 2 times 3 is negative 6, so our final answer is negative 6 radical 3. All right, let's take a look at number 2. Factor out the greatest common factor of 40x to the 4th y squared plus 16x squared y cubed. All right, so if you want to use your calculator for this, you go to Math, and then you go over to Num, and then you choose choice 9. All right, so I would type in 40, 16, and that tells me that the largest number that goes into both of those is 8. So my GCF is 8, but then I also have to look at the letters. They both have x's. When they both have x's, we use the one that has the smaller exponent, so that would be this x squared here. So my GCF is 8x squared. Now they both have y's as well. The smaller of the two is the y squared, so the y squared goes over here. So my GCF is 8x squared y squared. Now I actually have to factor it out. So to do that, I divide both of these by 8x squared y squared, 8x squared y squared. The 8x squared y squared goes out front. I start my parentheses, and then we do the division. 40 divided by 8 is 5. X to the 4th divided by x squared, we subtract the exponents, so 4 minus 2 is x squared. Here, again, 2 minus 2 would be y to the 0, so we can just kind of cancel those out. When you get 0, when you subtract the exponents, you can think of that as just canceling out. So here, all I've got left is 5x squared plus 16 divided by 8 is 2. X squared divided by x squared, well, 2 minus 2 is 0, so the x's cancel out. And then we have y cubed divided by y squared. 3 minus 2 is 1, so I could either write that as y to the 1st or I could just leave it as y and be done with that there. All right, so that's that second one here. Number 3 says factor each expression. Okay, so this one has 3 terms. When you have 3 terms, you want to be thinking about m and a. All right, when there's 3 terms, that's the technique that we're going to be using is m and a. So we need 2 numbers that multiply to 36 and add to negative 12. So I'll go to my calculator, y equals 36 divided by x, bring up the table. I want to add to negative 12, so I'm going to go use the negative numbers here. Keep scrolling, 4 and 9 is 13, that's not going to do it. There it is, negative 6 and negative 6 will add up to negative 12. So this is going to be x minus 6, x minus 6. All right. Now on B here, I only have 2 terms. When there's 2 terms, you've got one of 2 options. It's either going to be dots or it's going to be GCF. And the way you tell is dots, it has to be perfect squares and they have to be subtracting. GCF is pretty much anything else. So if you don't have perfect squares and their numbers are being added together, you're doing GCF. If you have perfect squares and the numbers are being subtracted, you have dots. So the way dots works is we set up our parentheses and then we just take square roots. The square root of 4y squared would just be 2y, so we put 2 y's in the front. The square root of 81 would be 9, so we put 9's in the back. And then again, since it's the negative 81, the only way to have that is if one of them is positive and the other one is negative. So again, this one was a dots problem. Okay, number 4 says to simplify 3x plus 4 squared. So what you have to remember is that 3x plus 4 squared is really 3x plus 4 times 3x plus 4, and then we're going to have to do our double distribution. So we start with this one. 3 times 3 is 9. X times x is x squared. Again, because x to the first times x to the first, you add the exponents. That's where we're getting the x squared from. 3x times 4 is 12x. Then we go along the bottom here. 4 times 3x is another 12x. 4 times 4 is 16. We're now going to combine our like terms. When you're combining like terms, the exponents do not change, so this is just 9x squared plus 24x plus 16. Okay, let's take a look at what's on the back. Factor completely, which is code for factor twice. So we're going to start by taking out a GCF. Step 1 with these is always to take out a GCF, at least it is this year. And then step 2 is multiply and add or dots. All right, depending on whether you have 3 terms or 2 terms. So let's take a look at this first one. We're going to start with the GCF of 2, 2, and 24. Now most of the time it's just going to be this first number. But again, if you're not sure, you can always go to Math, Num, Choice 9, and figure it out. So this one's just going to be 2. So the 2 comes out front. We've got x squared minus 1x minus 12, which means I'm looking for 2 numbers that multiply to negative 12 and add to negative 1. So I go to y equals, I type in negative 12 divided by x, and make sure you have the negative sign in there, otherwise the table is not going to give you the right signs. And then I like to just always start at 1, so 1 minus 12, nope, not going to give me negative 1. 2 minus 6, nope. 3 minus 4, yep, that will work. So I've got 2x plus 3, x minus 4. Okay. All right, let's take a look at B here. So this one's only got 2 terms, but I'm still going to start with the GCF. So the GCF of 3 and 27 is just going to be 3. I take the 3 out. I'm left with x squared minus 9. And now because there's only 2 terms in there, that's where we're going to do our dots technique. So we've got the double parentheses. the square root of x squared is just x. The square root of 9 is just 3. So one of them is going to be positive, one of them is going to be negative. All right. Let's take a look at number 6. Subtract 3x squared minus 4x minus 2 from 2x squared minus 5x plus 2. All right, so the key here is to remember that from means first. So whatever comes after the from is what we put first. The other thing to remember with these is you need to add the parentheses. Even though they're not writing them in the problem, you've got to remember to add them on your own. So it's that in parentheses minus 3x squared minus 4x minus 2 also in parentheses. Now, in front of this parenthesis is a positive 1. In front of this parenthesis is a negative 1. The positive 1 doesn't change anything, so these can just come down and stay exactly the same. The negative 1 does change things. So this is going to go from being positive to minus. This is going to go from being minus to positive, and this is also going to go from being minus to positive. Once we've done that, it's just a matter of combining your like terms. So 2x squared minus 3x squared is negative 1x squared. Negative 5 plus 4 is minus 1x. And then last but not least, 2 plus 2 is just a plus 4. Okay. All right, last problem. All right, solving a quadratic equation. So these are very similar to the factoring problems. They've just got, that last little extra step that we have to do. And the reason I know they've got that extra step is this one says equals 0, where problems like this, it's just an expression. There is no equal sign. All right, so when there's the equal sign, we're going to have to do the extra little bit that we're about to do. Luckily, though, it starts off the same. All right, there's 3 terms, so I'm going to use multiply and add. So I'm multiplying to negative 27. That's my back number. I'm adding to positive 6. So let's type that in here. Negative 27 divided by x. Bring up the table. All right, 1 minus 27, nope. 3 minus 9, nope. That's not going to give me a positive 6. 9 minus 3, yep. That will give me a positive 6. So this becomes x plus 9, x minus 3. And then don't forget that it's equals 0. We've got a whole equation here that we have to solve now. Now, that part is very similar to everything we've done. This is the little extra part. Since this is x plus 9 times x minus 3 equals 0, that tells us that one of these two parentheses has to equal 0. So it's either going to be x minus 3 equal to 0, or it's going to be x plus 9 equal to 0. So when we solve these, add 3 to both sides, we get x can equal 3, or when we subtract 9 from both sides, we get x can equal negative 9. Okay, so hopefully that was helpful. The one last thing that I want to show you is just some checks. So on number 7, this is an equation, so we would check that the same way we've checked equations all year long. You'd put the left side of the equation into y1. We'd put the right side of the equation into y2. We would bring up the table, and then we would just check our answers. So one of our answers was x3, and you can see that y1 and y2 match there. Our other answer was negative 9, and you can see again that y1 and y2 match. So that tells us that one's correct. Now for any other problem, the way we can check these is we put the problem into y1. So let's just do, for example, 3a here. We would put the problem into y1. So x squared minus 12x plus 36. We'd put our answer into y2, x minus 6, x minus 6. All right, so let me just get that all typed in there. All right, so you'll see there the problem is in y1, the answer is in y2, and then when I look at the table, you're going to see that everything matches, and that's kind of my sign that that one checks out because everything matches at that point. All right, so hopefully this gets you ready for the test, and have a good day.